Welcome to this video lesson. This video lesson will cover the distributive property. As we have learned previously, a polynomial is an expression consisting of a variable and a coefficient, involving only the operation of addition, subtraction, multiplication, and non-negative exponents. So for example, 4x y cubed plus 3x is a polynomial with two terms. The two terms are separated by a plus sign over here. We call this a binomial because it has two terms, and two terms is associated with the word bi, therefore binomials. Now, a binomial can be multiplied or divided by a constant or even another term which involves both constants and variables. The result of this is called the expanded form of the polynomial. When a polynomial is expanded, each term of the polynomial is multiplied or divided by the constant or the term that is present. This is called the distributive property. When we're multiplying a constant or a term by a polynomial, what we have to do is we have to multiply the term by every term inside the brackets, or every term of the polynomial. So, for example, here I have a multiplied by b plus c. The constant term here is the a value, and the polynomial here is b plus c, which is actually binomial. And it is binomial because it's classified by two terms separated, b and c, separated by a plus sign. So to expand this, or to use the distributive property, what we have to do is we have to multiply the constant term a both by b and the c value, resulting in ab, which is a multiplied by b, plus ac, which means a times c. An example over here shows 2 times 3x plus 5. First of all, the constant term here is the 2, and I have a binomial over here. So I have to multiply the 2 both by 3x and by the 5 over here. So when I do this, I get 2 times 3x plus 2 times 5. And to simplify this further, 2 times 3x gives me 6x, because I have to multiply the numbers together, 2 times 3 giving me 6, and the x stays as x, and then I have 2 times 5, which would give me 10. Now, before looking at the next example, let's review the addition of fractions. So let's look at 3 over 2 plus 5. So if I want to do this, I have to get a common denominator of 2, so it becomes 3 over 2 plus 10 over 2. And what I've done here is I have written 5 as 5 over 1, and the denominator is multiplied by 2 here, so 1 times 2 gives me 2. And if I multiply the denominator, I have to multiply the numerator by 2 as well, which gives me 10. To simplify this, I will have to write it as 2, 3 plus 10, and finally that would give me 13 over 2 as my final result. As you can see, I have 3 plus 10 in the numerator and the 2 in the denominator, and that's equivalent to saying 3 over 2, which is over here, plus 10 over 2, which is over here. So far we've been going forward in this direction, but today we're kind of going backwards. So we're saying if 3 plus 10, which is which you can kind of say as a polynomial, is divided by a constant, that's similar to saying 3 is divided by 2 and added to 10 divided by 2, which is over here. So these two are equivalent. We've always been going forward. Now we know that we can also go backward if needed. So going back to the example that we're doing now, the numerator is written as 6x plus 14, and the whole thing is divided by 2. So this means that I can break this down to 6x divided by 2 plus 14 divided by 2. So what I've done is I said 6x divided by 2, so that's my first term divided by the constant, plus my second term divided by constants, which has given me this. Now to simplify this further, 6 divided by 2 gives me 3x, and 14 divided by 2 gives me 7. And this is the most simplified form of the fraction. Now, another way of thinking about this is same as saying 6x plus 14 multiplied by 1 over 2. So I will write that down over here. So this is same as saying 1 over 2 multiplied by 6x plus 14. So here if I multiply my numerators together, 1 times 6x plus 14, I get 6x plus 14. And if I multiply my denominators, 2, and an invisible 1 over here, 2 times 1 gives me the 2. And if I were to use distributive property here, I could also do it this way. This is just another form of doing the same question. 1 over 2 times 6x plus 1 over 2 times 14. And that's same as saying 1 over 2 times 6x is same as 6 divided by 2, or 6x divided by 2, which is 3x, plus 14 divided by 2, which is 7. So you can see that there are different forms which pretty much mean the same thing, and that's what you got to be careful when you're doing these questions. You have to know that there's many different ways of getting to the same answer, and there's no right or wrong method. Just use the one that you're more comfortable with, but be familiar with all the forms. Now, sometimes you will face situations in which you have a polynomial and you have a negative value behind it, and there's no number or a constant or a term here that you can distribute. So there are two ways of looking at this. The first way of getting rid of the brackets or expanding the brackets or using the distributive property is to change each positive or negative sign of the term that were inside the parentheses. So here what we can do is, if you think of the first term over here, this is a positive term. Since there's a negative behind the whole bracket, the first term becomes negative, and the second term is also positive, so from positive it changes to negative. So this will become negative 3 minus x squared. Now, because of the negative sign that is left of our brackets over here, we can instead assume a coefficient of negative 1. So instead of the negative, we can write this as a negative 1, and we can then distribute that negative 1 to each term. So I will rewrite this. Instead of negative 3 plus x, I can assume that there's an invisible 1 over here. So I can rewrite this as negative 1, 3 plus x squared, and then distribute the negative 1 to both of my terms, making this negative 1 times 3 plus negative 1 times x squared. And when I write it as this, I get negative 1 times 3, which is negative 3, and I get a positive and a negative here that multiply together to give me a negative 1 times x squared, which is negative x squared. So once again, what we've done is we assume that there's an invisible 1 over here, and then negative 1 times 3 gives me negative 3, and negative 1 times x squared gives me negative x squared. Now let's do a few examples here. The first example that I have is x times y plus 1. So far we've been dealing with just constants, but now we have a variable in here, and the concept is the same. We're still multiplying what's to the left of the brackets with what's inside the brackets over here. So inside the brackets I have a polynomial which has two variables, meaning that it's a binomial, and that binomial is being multiplied by x. So what I will do, I will multiply the x by y and x by 1, and I will end up getting x times y is just xy plus x times 1, which is 1 times x, or x times 1, and 1 times any number is just equal to itself, or x, and I cannot simplify xy any further, so I get xy plus x as my final answer. For the next example, I actually have nothing to distribute, so I can think of this as an invisible 1 over here, not a negative 1 anymore because there's no negative behind it, and the 1 multiplies by 3 and 1 multiplies by a squared, and that gives me 3, which is 1 times 3, and 1 times a squared is just a squared. So you can see that if you have a bracket of polynomial and there is nothing to the left of it, or if it's just a positive value over here, it means that you don't even have to put it in brackets. You can just get rid of the brackets because it's already as simplified as it can get. Let's do one other example here, and we will do a times 3 plus a squared. And to solve this, what we will do, or to simplify this, or to use the distributive property, we will multiply a by 3 and a by a squared. So then we will get 3 times a, or a times 3. Similar, when you're multiplying, it doesn't matter which one goes first and which one goes second. And for good term, you always try to have the number first, so that's why I have the 3 first, plus a times a squared. So then I have to check to see whether I can simplify this any further. So 3 times a simply just gives me 3a. I cannot further simplify that. And a times a squared, when you think of this, you can think of a here as having an exponent of 1, and I'm now multiplying two powers with the same base, so I will keep this base the same, and I will add their exponent because I'm multiplying, and this finally simplifies to 3a plus a cubed. And this is as far as I can simplify. I no longer have like terms, so I cannot really add them together. So my final answer is 3a plus a cubed. Now, in terms of what steps you really need to show for these are one-step solutions. You can show this intermediate step over here as an option, but really you should be, after doing much practice, you should be able to get from this form to this form in one step. And similarly in the middle question over here, one step will be enough to show that you have an understanding of doing this type of problem. In the next example here, we will do the exact same thing as we've been doing before. We have a term being multiplied by a binomial, so we will multiply that term by both components or both terms in the polynomial. This time I have a negative in there, so I have to multiply negative x squared by 2y, and then add that to negative x squared multiplied by negative x squared. So let's simplify this a little bit further. So here I have negative x squared times 2y. That will produce negative 2x squared y. So I'm just multiplying all the terms. So negative goes first, and then in terms of having good form, we always want to have the number next, and then we want to try to have these in alphabetical order. So I have x squared y, and then for the next one I have plus negative times a negative, so a negative times a negative gives me a positive, so I will write positive. And I have x squared times x squared. I can simplify this a little further, not the first term, but for the second term here I have the same base, so I'm multiplying two powers that have the same base, so I have to add their exponents, 2 plus 2, and that should give me x to the 4 as my final simplified form. So my final answer will be negative x squared y, negative 2x squared y plus x to the 4. Just to check my solution, I can see that I had a polynomial here, and since this was a negative over here, the first rule that we kind of showed was that if there's a negative behind this, when you are expanding it or distributing it, it will change the signs on every term. So here my sign is positive, and that negative makes it negative over here. That is correct in terms of signs. And I have a negative over here, and that negative will have to change the sign to a positive, and that's what I get over here. So again, negative x squared times 2y gives me negative 2x squared y, and negative x squared times negative x squared, the negatives will make a positive, and x squared times x squared gives me x to the 4. And this will be more of a two-step solution. Can be done in one step, but it is nice to show at least two-step for these type of questions. In the last question over here, I have 2m times n minus 3m, so I will use the distributive property, and I will distribute the 2m to both terms of my polynomial, and this becomes 2m times n minus, because I have 2m, which is a positive, multiplied by a negative, which gives me negative 2m times 3m. So then this becomes 2mn as the simplified form, and then I get the next thing, I have 2m times 3m. So to simplify this, I have to multiply the numbers together, 2 and 3, and that gives me 6. And m times m, that is same as writing, so actually I'll write this here, 2 times 3 times m times m. The m's both have exponents of 1 because there's only one of them. They have the same base, so I will keep the same base, but I have to add their exponents, 1 plus 1, and that would give me 2 as the final exponent. Now, when I was doing this question, what I did was I did 2m times n, and then in this step over here, I realized that I have a positive being multiplied by a negative, and I wrote a negative there right away, and then I multiplied the 2m by 3m. One other way that you can look at this, and I will do that over here, is I can distribute it by saying the first step is the same. So I'm going to put a dash mark over here because this is just a different way of doing the same question. I get 2m times n plus, then I will have 2m multiplied by negative 3m, because here I have the 2m multiplied by the negative 3m. And it should give me the exact same answer. In the first one, I realized right away that I have positive times a negative, so this whole term becomes a negative, so that's what I did. In this case, I just wrote it instead by using steps, saying 2m times n over here, and then 2m times negative 3m over here, so I'm adding that in. So then in this step, I get 2mn, and then here I have a positive times a negative, making this whole term a negative. And 2 times 3 gives me 6, and m times m gives me m squared. So I should get the same answer solving it using both methods. In terms of marking, this would be more of a one-step answer, and you can also show this as an optional step. Here is another review of collecting like terms. So collecting like terms is the process of adding together terms that have the same variable parts in order to simplify an expanded expression. To simplify and expand expressions. That's what we want to do. So, for example, the first one over here, terms 4 and 3, are they like terms or are they not? So when we want to figure this out, first thing we do is we kind of look to see if they have the same variable types or constant types. So in this case, these two are both constants and they have no variables attached to them. So they are, yes. And the justification is that they are both constants. So they're both constants, and you can think of it in another way and say whether or not you can add these two together, and we know that 4 can be added to 3 and we can get 7. For the next one over here, I have 4x and 3. They don't have the same variable parts, therefore they are not like terms. So no, don't share same variable parts. The next case, I have 4x and 3y, and it's the same situation. I don't have the same variable parts. One of them is x and one of them is y, so this is also no, and for the same reason as above. For the next case, I have 4x and 3x, so now they have the same, they both have constants and they both have the same variable part. So therefore this is yes. Have or share same variable parts. Now the last situation, I have 4x and 3x squared. And even though it seems as though they have the same variables, which they do, they have x and x, but one is x and one is x squared. So in terms of variable parts, they don't have the same ones, or they don't have the exact same ones. So to put this into perspective, you can think of x as a one-story house, and you can think of x squared as a two-stories house. And you can't really say that you can add 4 one-story house to 3 two-stories house, because they just don't add up. You can't say they will give you 7 one-story and two-stories houses, because 7 one-story and two-stories houses means 7 of each. So you can't really separate them. So you can always think of it that way. The x here, if it's just x and it doesn't have the power of 2, it's one-story house. This is two-stories house, and you just can't add them up. Now, if they were both x squared, then you would have 4 two-stories house plus 3 two-stories house, and then you can say you have total of 7 stories house. But when they don't have the same power, you just can't add them up. And therefore the answer to the last one is that no, they are not, because they don't have the same variable parts. Now, let's distribute the following expression and simplify it as much as possible. So, and simplify. Let's add that to the question. So, in the first question, I have 5 minus 3x plus y plus 3x minus, brackets, 2x minus y. So, I have to use a distributive property. For the first one, I don't have anything behind the bracket, so you can assume an invisible 1 being distributed. So I will get 1 times 5, which is, I'll write it in steps first, 1 times 5 minus, because positive times a negative is negative, 1 times 3x plus, same thing, I don't have anything, so I will add an invisible 1. So I will get 1 times y plus 1 times 3x. And then I have a minus. Assume there's an invisible 1. Negative times a positive, so negative times a positive gives me negative. So then I have negative 1 times 2x. And then I have negative times a negative gives me a positive. So I will have plus 1 times y. So to simplify this, 1 times any number is itself, so I get 5 minus 3x plus y plus 3x minus 2x plus y. Now, before moving on, just one thing that you have to be very careful, this is the most common mistake that students often make, is that when you have a negative here, they multiply the negative by the 2x, as I did here, but they forget to multiply the negative 1 by the negative y, and they just leave this as negative y, and they forget to really distribute that negative. But moving on here, I will collect my like terms. I can see that 5 is the only constant amongst all the terms, so I will have 5. And then in terms of like terms that have x as their variable, I have negative 3x plus 3x minus 2x. So for this step, I will just write everything together. And in terms of the variables or like terms that involving y, I have 1y over here, 1 over here, making this plus y plus y. In my next step, I will simplify 3x and the negative 3x and the positive 3x will cancel each other out, giving me a final value of 0. and subtracting that by 2x gives me negative 2x, and y plus y is equal to 2y. Now, one other common mistake that students often make is when they add y plus y, they write 2y squared or y squared. So one thing to pay attention to at all times is that you cannot change the exponents of these if you're just adding them together. The only time you add to the exponent is because you are multiplying things together. So for example, I'll write that separately over here. If I had y times y times y, that would give me y cubed, because that's a simplified form of writing y times y times y. But if I had y plus y plus y, that would give me 3y's, because I have a total of 3y's now, and that's the way we simplify addition. So be very, very careful when you're adding things together. The variable stays as the same, because it's the same as saying 1 apple plus 1 apple plus 1 apple gives me a total of 3 apples. But when you're multiplying, the simplified form in mathematics is the exponent form, so that's why you get that exponent over there. Now, to finish off the question, in terms of writing things in good form, we always want to have our variables first. So here I have negative 2x plus 2y, and the reason I wrote negative 2x first is because x, in terms of my variables, x and y, x comes first in alphabet, and so I write negative 2x plus 2y, and I will leave my positive 5 at the end in order to write this as the most simplified form and also in a good form. In terms of showing steps, I have spent 5 different steps to get to the final answer, but you don't have to show all of them. In fact, the only ones that you really need to show are 2. One is your ability to be able to use distributive property properly, which is this one over here, and the other one is your ability to simplify and collect like terms, so you can get to the final answer over here. But you can also show some optional steps as well, but you don't really have to show these. Now for the next question, I will draw a line in the middle over here so that we know we can separate or distinguish the two questions from each other. For this one, I will do the exact same thing as I have been doing before, and I will distribute the terms that I have outside of the brackets into the brackets. So on the left side, I will distribute the 2x, and on the right one, I will distribute the negative 5. So on the first step, I have 2x multiplied by x, and then I have 2x times negative 3, making this a negative, and 2x times 3. And then I have negative 5 times 4, so that's negative 5 times 4. And then I have negative 5 times negative x, so negative times a negative is positive. And I have 5 times x. And finally, I have negative times a negative, which gives me positive. And I have 5 times x squared for my term. My next step is to write each term in most simplified form. So I have total of 1, 2, 3, 4, 5 terms, which are separated by plus and minus signs. So the first one I have 2x times x. Everything is being multiplied, so my number stays the same. I have x times x, both have the exponent of 1. Their base is the same, so I will keep the base. Add their exponents, 1 and 1, so I get 2x squared minus. For the next term, my numbers multiply together. 2 times 3 gives me 6, and the x stays. For the next one, I only have numbers being multiplied together, so I get 5 times 4 is 20. Next one I get 5x, and that's as simplified as that can get. And my last one is 5x squared, so that stays the same as well. I now look for like terms. For x squared, this one is x, this one is constant, this one is x, this one is x squared. So these two are like terms, so I will underline these. These two are like terms, and I will leave the final one, or what's left, without any underlining. So I will have 2x squared plus 5x squared minus 6x plus 5x minus 20. So now I will start adding things together. 2x squared plus 5x squared, that's like having 2 apples plus 5 apples, and that gives me a total of 7 apples. And then I have negative 6x plus 5x, that's like taking away 6 oranges and then getting 5 oranges. So you will have a total of negative 1 orange, or just negative x. And finally the number stays the same, so I get negative 20 as my final value. So in terms of good form, I have my constants at the very end, and I have my variables in front. Both variables are involve the letter x, so I don't have to put one before the other. And this one has x squared, so it usually goes first, and then the x, which doesn't have an exponent, or I mean it has an exponent of 1, which is smaller than the 2, goes second. So this is also in good form. In terms of steps that you have to show for this, one, really to show that you're able to distribute things properly, and one is to show that you can collect like terms and add them properly to get to a final answer. One middle step over here can also be very helpful to show your teacher that you really understand how to collect like terms. Now there's one common misconception that often happens that I just want to mention before ending this video, and that comes up when you have questions such as x, y versus x plus y. Note that when you have something in brackets, it simply means that you're multiplying things. So here, in the first case, I have x being multiplied by xy, and in the second case, I have x being multiplied by x plus y. As we saw earlier in the description of the distributive properties, when you're multiplying a term by a polynomial, and that's the only time that you really distribute the x to both terms. So for the first one over here, I don't have to distribute the x to both the x and the y. So I cannot say that this is equal to x times x times x times y, because then I would be doing this, which I really can't do. So I will erase that. So I cannot say that these two are equal, but I can say that this is equal to x times y, which is then x times x. They both have exponents of 1, same base, so I will keep this base, but I will add the exponent, so I get x squared y. It is very, very important to be able to do this, because sometimes the brackets are present, but they don't really mean anything other than multiply. So this simply means x times y, which is x squared y. In the second case, I have a polynomial here in which these two terms are being added, so then I will have to distribute the x to both of these. So then it will become x times x plus x times y. And x times x gives me x squared, but I cannot simplify the second term any further, so I will get xy as my second value.